Hello, everybody. My name is Randall Stemmel. I am the CEO of Bricks Technology, also of PMET, Pittsburgh Mineral and Environmental Technology, which is the laboratory side of our operations here. So today I'm going to be speaking about the being able to beneficially reuse CCR material to manufacture lead construction materials without creating additional waste. Sounds pretty exciting. So, um, so when we first started this journey, we were looking at this as an environmental thing. We're not just here to build another mousetrap, right? We don't want to build a better way to burn off carbon. We actually want to come up with a real solution. We want our solution to be environmentally friendly. We don't want to produce as minimal amount of CO2 and use as minimal amount of energy in our process. To be part of that environmentally, we want to make sure that we encapsulate. So if there is any kind of toxins or any kind of nasty stuff in the fly ash, however it got there, mercury, arsenic, whatever, we're going to encapsulate that to make sure that our final product doesn't leach into the ground around it. And we also need to make this solution to be financially viable and to make a product that we can sell. You guys probably know this more than I do. 700 plus impoundments, over 200 billion cubic yards. How much is going to be coming back onto the market in 2024? We still don't know, and will we be able to use the impounds? So just kind of looking at some of our technology here. So I like to call ourselves a remediation manufacturing company because we're remediating, but we're also manufacturing a product that we sell on the market. One of those is a brick or paver, any kind of shape. In our process, we're going to be compressing the material, the feedstock down. When we do that, it's almost the exact same kind of process that a brick manufacturer uses. We change out the kiln there to make it more environmentally friendly. So that's why you can see that our CO2 is over half of what the traditional brick manufacturing business does. And then for every cubic meter of bricks, 53 kilogram CO2. And then just for a little reference too, concrete is 900 kilograms of CO2 when manufacturing concrete. Here gives a nice little chart. You can see, oh, he's got the pointer right here. Okay. Let's see if I can. I'm sorry, I'm trying to figure out how to use the little pointer thing. Oh well. Oh, there it is. Okay. So other industry, flaring, oil and gas, we all know about that. Cement is right up here. Coal is down here. And then we're going to take fly ash and we're going to run it through a kiln to burn off the carbon and dry it. So now we're just adding on more CO2 to this to add into the cement, which is going to far out exceed everybody else on the market. So looking at the CO2 and understanding that we're producing far less CO2 than your normal brick and block and aggregate and cement manufacturers. So that kind of gave us that. The other process is the encapsulation. So this is a 2000X SEM image of fly ash before a thermal curing process. So during that process, we use 100% CCR. We add in 2 little binders to it, and then we run it through a thermally curing process. And in that process, we create crystals, and you can see all these flat surfaces here of growth. And those crystals, which is called tobermite, that actually will encase and encapsulate anything in there. So let's say there was mercury in there. That is now encapsulated. It will not leach into the ground. If you were a mason and you cut that and you breathe that dust into your lungs, it processes right through your body just like any other dust would. It doesn't leach into your system. This is another way to make sure that we are environmentally friendly and making sure that we're not leaching any kind of things, because as we all know, we're on an uphill fight with everybody. Everybody thinks that we're, polluting the grounds and all this stuff like that. So this is one of our ways to be able to show that we're not going to be producing, or we're not going to be leaching into your surrounding grounds or waterways. So I don't know if anybody's dealt with Dr. B from Ohio State. He's kind of a fly ash guru. If you ever go to WOCA, he's on the board, sharp guy. So what we did was we used Ohio State's laboratory to perform a third-party testing of our products. We used 100% fly ash for this one. We've got over 10,000 PSI for compression, bottom ash, and fly ash. We're over 10,000 on those two. For reference, a red brick is 3,000 PSI. Your heavy pavers, which you can use for parking lots and stuff like that, is 8,000. The other part of that process is the water absorption. As you can see right here, we actually did a little bit better with the bottom ash. The bottom ash is a lot more coarse, so it gives a little something more to grab a hold of, and to creating those crystals. So we have a really low water absorption here, which then is another mechanical requirement for your pavers. Bricks, they actually don't really have a absorption for your house. They don't actually have an absorption kind of rate, but the pavers do freeze thaw. So then we went out and we presented our findings and everything that to the Green Building Association here. We're able to offer 4 points for a LEED Gold project, and then 2 more points for the sustainability site. It's a total of 6 points, which is about 10% of your gold points that you need to accumulate for your project. Here's some other kind of federal tax incentives and stuff like that. They're roughly estimating $68 billion per year green materials market in the United States. There's really not anything out there for a masonry product or any kind of cement, and we're hoping to change that. So our initial pilot plant, this is actually in the back of our warehouse. So we were able to get a grant from the Pennsylvania DEP to prove out our process and theory on a large scale process. We sampled from 8 different power plants throughout the eastern Ohio region, the western part of Pennsylvania, and down into West Virginia. So we sampled 8 different plants, run all their products through there. We took in the stuff that was impounded, the stuff from landfill. We didn't use any kind of fresh ash for this process, because the fresh ash right now is already competitive with the cement. We're not really wanting to compete in that space. We want to provide a solution for what's already been landfilled and how to get that out and clean closure sites. In this process here, we've proven out our technology on all of these sites, the materials, and patented the technology. Our first manufacturing facility went into operations back in 2018. It is in India. The plant does 60+ million bricks a year. This is our bricks facility here. And the company actually was a steel manufacturer. Steel manufacturer needed better power. The grid there was a little bit wonky on them, so they built their own coal power plant. Then the Indian government came in and said, no, you're no longer allowed to landfill any of that. That's when they approached us. We helped design the facility. It's 420 tons per day, 60+ million. So that's roughly right at almost 2 million tons of fly ash that's been beneficially reused. That doesn't work. So here's some. This right here is a This is an apartment. This is a vocational school here being used. Just a guardhouse coming onto the property, and then the driveway and the yard. It's all made up of the pavers from that site. So our first phase here in the United States, we acquired a 20 million ton facility in Ohio. The site has been accepting ash since '94, about 20 million tons on there. We have a plant up. We're starting off at 260,000 tons per year. Making brick, block, and aggregate and sand, and then we're making an additional 80 tons per year of cinder blocks. We've already received Ohio DO2 approval for our bricks, blocks, cinder blocks, and aggregate and sand. All those can be used on any ODOT approved project. As far as the aggregate can be used in the concrete, or it can be used as a base, either way. The EPA, Ohio EPA, actually issued us the very first beneficial reuse permit in Ohio. They did not have a program for beneficial reuse, so we kind of blazed a trail there. So we're able to do that. The EPA, we talked to our district chair with the U.S. EPA. They issued us a letter. It's very vague. They don't want to make a decision, but basically it says it looks like you have checked all the boxes for the beneficial reuse definition, which is kind of nice that they actually even did it. Our second phase, we're going to build a brand new facility on that site with more presses and more thermally curing vessels here. We're going to do 1 million tons a year, and then an additional 400,000 tons per year. So on the output side, we'll be intaking, for us, if we intake 1 million tons, we produce 1.1 million tons of product. So that kind of gives you how much CCR we use compared to just our binders. We don't use any other things like that. There's no sludges or anything like that. If I screw up a line here of product and it doesn't meet the mechanical requirements, all I have to do is take it, put it around the back, crush it, send it right back through my process. So I'm not producing anything. I'm not producing any kind of air pollution. We've had our thermally curing process checked by the EPA along with other universities to verify that we're not putting out any NOx, SOx, or any of that bad stuff. Because our process is very clean, we're not producing any kind of sludges or anything like that. It's just our binders plus the CCR material, press it, thermally cure it, and we're done. Like I said, we can make cinder blocks here, pavers, bricks, and all kinds of different other shapes of bricks and sizes. Our only limitation is the mold that we can press into. So we have a brick press from Colombia. We have over 10,000 different kinds of molds that we can put into different shapes and sizes of bricks, blocks, pavers, all that kind of fun stuff like that. Then our other product is our aggregate. So we'll be producing aggregate and crushing it to the size that the concrete company or whoever needs it. These are just some quick lab samples here. We'll be producing a 2-inch by 2-inch by 2-inch briquette, like a charcoal briquette, will be our size. And then we'll crush that down to whatever the order is for whoever's buying it, road base, using concrete, whatever. At that same time, when we do that crushing, we produce sand, which is actually, if our product is, obviously LEED certified. So both our products here will be LEED. And sensing that concrete takes up 75–80% of concrete is made with aggregate and sand, that now the concrete actually will have a ability to say that they're green and they're no longer just pumping CO2 into it that everybody knows is a joke. Sorry if you're a concrete company. We have our process is pretty robust. So we're able to take in other kinds of ash, incinerated ash. We've taken in some incinerated ash from a Alcosan, which is a wastewater treatment facility in Pittsburgh. We've taken in their stuff. We've taken in oil and gas drilling cuttings around the Marcellus and Utica area to also do this. Coal refuge. We have another process for the coal refuge, but we are able to take it in. LOI doesn't really scare us too much. You know, when we get up into that 20% LOI and stuff like that, that's when material starts to become weaker. So we try to work around that. You know, dilution is a solution. Metal tailing, precious metal mining tailings, we're able to use that. Glass, slag, several other kinds of different waste we can all incorporate, either mixing in with the fly ash or using it as its own dredge material. We will have a plant here in Houston, Texas for dredge. So this is kind of, you know, not really ready for prime time so much, but I'll give you some insight of this. So I'll play this in 9 seconds. That's just a droplet of water, and that's fly ash. So we've been able to create basically a filter, right? A very porous product. We can use that for lightweight aggregate. We can also use that for linings for your leachate and stuff like that to get your flow. It's all encapsulated in there. Artificial coral reefs are something that we actually have two. I think it's 9,000 pounds. We have two 9,000 pounds. I don't want to say tons. That's ridiculous. But two 9,000 pound slabs that are going into Long Island right now. So in Long Island, there's actually will be two of these slabs put together. We've put some food into these pores right here to attract mussels and clams to help naturally filter out the material. So it's kind of a really, I don't want to say dumb, but it's kind of cool at the same time. So your shore here, the two slabs are right here, and so they're just detecting the water that's in there, see how blue it is and what kind of, how the filter is and stuff like that. So it's a pretty neat system. We'll also been able to prove out H2S, use it as a filter. H2S, we're in talks with a couple of nuclear power plants to use it in a filter of their process water. And then we're also looking at PFAS using the CCR filter. So we're looking towards the future to using about, right now we've got 150 million tons of fly ash under our umbrella. We're looking for more. Our build process is basically we find, you know, some place that has a landfill or whatever. We'll build our facility on the site. One, take it right there, make our product, and get it off your site. We're designing our facilities for 1 million ton to help with that production and get that off as quickly as possible. We are building a site in Arizona right now. It's going to be a 1 million ton site per year, which will increase to 10 million tons per year within 2 years of commissioning of the first plant. Any questions? It's 250 Fahrenheit and 200 psi. Ish. I'll say ish. But if you'd like to sign the NDA, we can get in more detail. Yes. Mm-hmm. Yep. So one of the really good things, the fly ash, you'll see some kind of stuff in it and stuff, but the mining tailings, that's where we see a lot of mercury and arsenic and boron and stuff like that. So those are ones I like to show people and say, okay, this is some nasty stuff. Your stuff's not going to be this nasty, but this is nasty, and this is your teacup. This is our teacups after, to prove out that they are encapsulating everything. We can also, cut it and let you look at it and stuff like that too, but that's how we do it. Awesome. I will turn it over to the next guy.
Thank you, thank you. Apparently I'm the moderator, so I'm just saying I'm moderated.
You can take as long time as you want.
Yeah, plenty of time.
And thanks for coming back. I wasn't trying to put pressure on.
You're not.
I want everybody to have one of these. You're going to find out what it is here in a minute. Some of you may already know this. I'm with a company called World Domes. Some of you would recognize Dome Tech International. I already saw a picture of one of our domes on Steve's presentation in Bruner Island. So they are all over the place. Thank you. Before we get started in the presentation, I do get the sense that I'm in the presence of a few engineers, a few scientists, a few, which I think I'm correct in. So let's mess with your head for a minute. Sometimes these presentations, unless you're right in the middle of it, can come across as being rather inactive. So let's see if your math head works. Some of you've seen this before. I don't want you to tell anybody. I want you to pick a number in your head between 1 and 10. Okay? Now we're going to do just a small series of math questions. So if you were my buddy, you'd be in trouble, but hopefully it's not too bad. If that number that you picked, I want you to times it by 2. Add 8. If that number, new total, divide by 2, and then minus off the original number you picked. Okay? So everybody should have a new total. Now what we're going to do is we're going to convert that total to a corresponding letter. So if your total was 1, it would be A, 2 would be B, 3 would be C, and so forth. So now you've converted your number to a letter. You're going to take that letter, and you're going to think of the name of a country that begins with that letter. And you're going to go to the next letter in the alphabet. You're going to think of the name of an animal begins with that letter, and what color that animal is. And most of you will figure out that you won't see very many great elephants in Denmark. How many have gray elephants in Denmark? A few of you. Anyway, my name is Ted Parkins, and I am with World Domes. Little history real quick. We were Dome Tech International for almost 30 years. In the mid-90s, my boss, Mike Hunter, who was actually scheduled to be here, he was in business with a gentleman named Barry South. And he had a company that did this process of building domes. It's fairly new, it's only about 40 years old. The very first one was invented, it's built in Idaho to store potatoes. And it has morphed. We actually don't store potatoes in it anymore, but for a few, just because of the refrigeration that is needed to store potatoes, it wasn't quite effective enough. But what happened is the inherent strength of a dome, the shape of dome is so strong that we started finding out that there was other materials, anything bulk, that would store in this dome very effectively. So you have your clays and your anything of powder, cement, fly ash, coal ash, anything that's granular like a clinker or a fertilizer.